Thanks very much. Can I first thank Pat Langley? I've not been a member of this community for rather more years than I like to admit. And he suggested I submit a paper. And thanks also to Matthew Klenk for his patience in helping me get my paper in. In fact, I was a member of this community a long time ago. I was a postdoc with Alan Newell and Herbert Simon at CMU. But when I returned, I got interested in applying AI in medicine. And after I returned to the UK, I started a project. Whoops, why is this? There we go. Which at that time, the way that you developed systems to help doctors was to use maths, of course. And this was actually a very early system for diagnosis that was on a doctor's desk in a UK hospital. And it used simple Bayesian methods for assessing the likelihood of different diagnoses. That convinced me that it was quite successful in some ways, but it was a black box, as everybody talks about now. And I went on from there progressively to take a cognitive approach. And this is a quick overview of many years of work with many other people, which I summarize as the CREDO Stack, which starts with a lot of empirical work on medical expertise, theoretical work, and increasingly around knowledge engineering, knowledge modeling, and cognitive system design, and validating the theoretical work as well as the engineering in applications. This talk is just a brief word about why medicine is an interesting challenge domain. To summarize some of the requirements of what we have to do to build systems that might be useful to people in difficult and complex circumstances. I'm going to quickly run through from bottom to top those topics, assess the work, and then a wrap up. Oh, if anybody's interested, the paper we have a little demonstration that we put together recently, published in a journal called Learning Health Systems, which is a system to help on various aspects of decision-making and management of patients with COVID-19 infections. And that's online. And if anybody wants to have a look at it, and you look at the paper and the details are there. So medicine as a challenge domain, it's actually been a hugely attractive domain for countless people in countless disciplines, psychology, AI, computer science. The last bit of AI was around expert systems and knowledge engineering, for those of you who are old enough to remember, and even some work in autonomous agents. It's a hugely challenging area. There's a vast range of cognitive and other tasks. The kinds of beliefs, goals, plans that clinicians have are very complex. Uncertainty is endemic about what to believe, what to do, what the requirements are. And situations are constantly changing. I'm understating the complexity here. And there's oceans, Sergey will like this, there's oceans of background knowledge, which in a skilled human doctor, large amounts of it, even which are not instantly relevant to a particular medical problem he or she is trying to address, can pop in as relevant and helpful. That's something which is a really important thing to confront in building artificial agents. Starting from the bottom of the stack, we've done a lot of work on working with many clinicians in many settings, trying to understand what they do. We've done lots of lab work on simulated medical decision-making, very much in a psychological perspective. Don't do that much anymore, but I've worked with Rick Cooper, who some of you will know, and we've done a lot of systematic modeling of the cognitive processes and these laboratory tasks, and learned a lot from that. This led me to some firm doubts about traditional ways of thinking about decision theory, still hugely influential and powerful, but when faced with a domain like medicine, very limited. Also some critiques of knowledge-based and expert systems, which I still very much influence what I do with my colleagues, but particularly from the point of view of field like medicine, which is safety critical. We need very strong principles, design principles, and formal foundations to build and deploy systems that could kill people. But the other thing I think is, this is all before Alan Newell's book, but I kind of recognized afterwards an increasing commitment to the vision that Alan had of unified theories of cognition. And that really, the rest of this talk is try to kind of bring out the take that I have on a kind of unified theory of medical cognition, and to ask the question, does this theoretical framework, is it applicable more widely into areas that you're interested in? There's actually a paper which provides a kind of useful benchmark for anybody who's interested. So what should a unified theory of medical cognition cover, in my humble opinion? Well, it's clearly a large part of what we all do and doctors do, is goal-based tasks and activities, monitoring situations, acting on them, reasoning about them, interpreting situations, making predictions, assessing risk, decision-making, changing decisions, revisiting decisions, planning and replanning. We've heard a lot of those things touched on in the last 2 days. I've heard something which I've always been interested in, but we haven't done, and I don't know how to do, and I think there's people here who may, which is, I think people build narratives around their patients. And that's a very important and a very rich representation of the situations that they're doing all the other tasks around. So there's a number of people in this meeting. I'd love to pick your brains. Interestingly, in medicine, and I'll give you the justification for this later, perhaps we may not need much more, in fact, to do goal-based cognition pretty much across medicine and maybe other areas. Metacognition, on the other hand, self-awareness, psychology, our confidence in our decisions, learning and acquiring new knowledge, working with other people, providing explanations, discussion, debate, negotiation. These are all things which require a level of expertise, and I don't think this scratches the surface of the understanding we need to develop for metacognition. We've made a bit of progress. I'm sure other people in this meeting have as well, but there's a hell of a lot more to do. So this is what I call the domino model. I'll show a picture of it in a moment. Essentially, sorry.
No, that's right. I was
Is everything
I had
okay?
headphones in, so I wasn't sure what I
Sorry. Can you still hear me? Can anybody hear me?
John, I can hear you. This is Adam. I was on the previous talk. I believe Irina's mic needs to be muted.
Okay, right.
I'm sorry, I'm trying to mute her. Irina, is there a way to mute a participant? I think we're good now. Why don't you go ahead, John?
I'm going to briefly talk about something called the domino agent, and the key feature of that is it's very much based on like folk psychology or theory, or these sorts of things. We've tried to capture very familiar mental states, beliefs, goals, plans, etc. But they're the heart of this framework rather than an architecture, which has a minor role in our work. We identified several different kinds of reasoning and strategies, particularly for dealing with uncertainty, to represent these different kinds of states. We've done a lot of work on decision theory, trying to develop an alternative to conventional mathematical models, which I think we've had some success with. Again, based on a very straightforward common sense understanding of how we all argue, formulate arguments and aggregate them, making decisions, or many of the decisions we make. And although I'm an experimental scientist by training, I've been influenced by hardcore computer scientists and AI people, and tried to provide foundations with help from other people, particularly somebody called Subrata Das, who he and I wrote a book in 2000, which tries to kind of bring all these ideas together. And that's a kind of benchmark for us, covering a lot of this ground, particularly trying to think, how do you build cognitive systems that can be used safely in complex medical settings? This is a picture of or a visualization of the Domino model. It's obviously limited how much I can explain this, but essentially this is a set of components of an agent which are specialized for dealing with beliefs or goals, possible worlds where there are multiple possible solutions to achieving goals, processes of making decisions, constructing and carrying out plans and actions, and so on. This picture here is we've done a lot of prototyping of this framework using Rick Cooper's Cogent modeling platform, which some of you will know has been around for a good number of years. More recently, I've been trying to move away from these rather seductive folk psychology terms like beliefs and goals, really to try to understand cognitive systems in a more canonical or abstract form. Rather than
have a bit more than a minute now.
Oh, right, thank you. I'll move quickly. So there's a canonical form. We've also done a lot of work on trying to structure knowledge, model different kinds of expertise using a task framework, and we developed a language called PROforma, which has been used for a wide range of systems with a lot of tools to build agents. I'll skip this. That was a view of a medical application in use. Lots of work since we published the book on working with other people to develop clinical trials and demonstrate these systems applications can be used to significantly improve on medical decision making. There's about 16 so far. I think there are references to this in the paper. And so to wrap up, that kind of program of work, the CREDO program, and the Domino model in particular, to me appears to be a theoretically credible framework for understanding medical cognition and a practical foundation for designing cognitive systems that can be used in healthcare. A kind of core production result was the PROforma language, with an application that routinely outperforms skilled clinicians on complex tasks. And my closing questions are, how much does this unified theory of medical cognition, if it's not too pompous to call it that, does it generalize outside the medical domain? And in particular, as I get to know you, I'm interested in the question of how does it align with other ACS traditions? And if it doesn't, I'm interested to understand why. Thanks very much.
Okay, thanks, John. I'm just checking to see if we have a question in the chat here. Let's see. So Sergey Nurnberg asks, he says, for a patient-oriented narrative to be useful, the generator must have a profile of the patient to adapt the text to the level of knowledge and understanding and language comprehension of a particular person. Do you have a response to that?
Yes, we don't principally start with natural language or text. We've done a certain amount of work of that, but most of it, the medical records, medical data are structured. So they're well-defined models of medical data.
All right, thanks very much.
Thank you.
There will be interaction in the Zoom rooms afterwards. I believe